Imagine waking up tomorrow morning, checking your phone, and seeing a breaking news alert. Astronomers detect rogue black hole headed toward solar system ETA 50 years. Your coffee suddenly doesn't taste the same. The traffic jam you're worried about seems meaningless, because in that moment, everything changes. But here's what will absolutely shatter your understanding of reality. A black hole doesn't need to reach Earth to end everything you know. In fact, if a stellar mass black hole, just 3 times the mass of our Sun, crossed into our solar system at the orbit of Neptune right now, you wouldn't even know it happened. Not immediately. You'd go to work, pick up your kids from school, argue about politics on social media, completely oblivious to the cosmic death sentence already being executed. And that's the truly terrifying part. What if I told you that the gravitational disruption would begin almost instantly, but the effects would unfold like a slow-motion apocalypse spanning decades? Neptune would be the first to feel it. Within months, its orbit would begin to destabilize. Jupiter would follow. And then, like dominoes arranged by an invisible hand over billions of years, the entire architecture of our solar system would collapse. But you still wouldn't see anything wrong. The sun would still rise. The seasons would still change. Until one day, they wouldn't. Here's the mind-blowing part that scientists discovered only recently. We've actually detected rogue black holes moving through our galaxy right now. In 2022, a team led by astronomer Kayla Shisiu at the Space Telescope Science Institute identified a stellar mass black hole drifting alone through the Milky Way, about 5,000 light-years away from Earth. They used gravitational microlensing, watching how the black hole's gravity bent the light from stars behind it to track its movement. It's traveling at about 100,000 miles per hour. And it's not the only one. Researchers estimate there could be 100 million rogue black holes wandering our galaxy like cosmic bullets, remnants of dead stars that were kicked out of their original systems by supernova explosions. Most of them, thankfully, are nowhere near us. But one day, our luck might run out. Before we dive into the simulation of exactly what would happen, I need you to do something right now. Hit that like button, because this video is about to take you on a journey that will fundamentally change how you see your place in the universe. And subscribe, because we're going to explore scenarios that textbooks are afraid to discuss in detail. Also, drop a comment right now telling me what country you're watching from and what time it is where you are. Are you watching this in broad daylight, feeling safe under the sun's warmth? Or is it nighttime, and you're alone with these thoughts? Because by the end of this video, your relationship with the cosmos will never be the same. Let's begin. Let's start with the basics, but I promise even these fundamentals will surprise you. What exactly is a black hole? You've probably heard this simple explanation. It's a region of space where gravity is so strong that nothing, not even light, can escape. That's true, but it's also profoundly incomplete. A black hole isn't just a cosmic vacuum cleaner sucking up everything around it. That's actually a misconception that drives astrophysicists crazy. Here's the surprising twist. If our sun suddenly became a black hole right now, just compressed down to about 6 kilometers across while maintaining the same mass, Earth's orbit wouldn't change at all. Not one bit. We'd still orbit at the same distance, taking 365 days to complete each revolution. The only difference? We'd freeze to death in the darkness because the sun would no longer be producing light and heat. But gravitationally, nothing would change. The mass would be the same, and mass is what determines gravitational pull, not density. This was proven mathematically by Carl Schwarzschild in 1916, just 1 year after Einstein published his general theory of relativity. Schwarzschild was actually serving in the German army during World War I when he solved Einstein's equations to describe the gravitational field around a point mass. He calculated what's now called the Schwarzschild radius, the size to which you'd have to compress an object for it to become a black hole. For Earth, that's about 9 millimeters. For the Sun, 3 kilometers. Schwarzschild died just months after making this discovery, never knowing that he'd unlocked one of the universe's most terrifying secrets. But here's what most people don't understand. There are different types of black holes, and size matters enormously for what happens next in our simulation. Stellar mass black holes form when massive stars collapse, typically between 3 and 20 times the mass of our Sun. Then there are supermassive black holes, the monsters at the centers of galaxies, millions or billions of times the Sun's mass. And scientists now theorize there might be primordial black holes, tiny ones formed in the first moments after the Big Bang, possibly as small as an atom, but as massive as a mountain. For our simulation, we're going to focus on a stellar mass black hole, about 10 times the mass of our Sun, because that's the most likely scenario. These form when stars between 20 and 100 solar masses explode in supernova and collapse. And here's the kicker. When a massive star dies in a supernova, the explosion isn't always symmetrical. Sometimes the dying star gets a kick from the uneven explosion, launching the resulting black hole through space at incredible speeds, up to 1,000 kilometers per second. That's how rogue black holes are born. Think of it like this. Imagine a spinning ice skater pulling her arms in to spin faster. Now imagine that skater suddenly explodes, but unevenly, so part of the explosion pushes her in one direction. That's essentially what happens to create a rogue black hole. And once it's moving, there's very little to stop it. Space is mostly empty after all. These cosmic wanderers can travel for billions of years, crossing entire galaxies, until they encounter something significant. Something like our solar system. Now, you might be wondering, wouldn't we see it coming? This is where things get genuinely unsettling. Black holes don't emit light. That's literally in the definition. We can only detect them by observing their effects on things around them. If a rogue black hole is traveling through the vast emptiness between stars, there's nothing around it to observe. No accretion disk of glowing matter spiraling in, no companion star being ripped apart. Just invisible, silent, deadly mass moving through the darkness. In 2021, astrophysicist Pedro Bernardinelli and Gary Bernstein discovered what they thought was a rogue planet at the edge of our solar system using the Dark Energy Survey. It turned out to be a giant comet, but the technique they used, looking for objects that very slowly move against the background stars over many years, is the same, one we'd need to detect an approaching black hole. Except a black hole wouldn't reflect any sunlight like a comet does. We'd have to notice its gravitational influence on objects it passed near. And if it's coming from above or below the plane of the solar system, where we have fewer objects to observe, we might not see it until it's far too late. Here's your first major revelation. The detection window for a rogue black hole entering our solar system could be as short as a few months to a couple of years before significant effects begin. Not decades, not centuries. That's barely enough time to confirm what we're seeing, let alone do anything about it. And here's what will blow your mind. There's literally nothing we could do anyway. No technology we possess or could feasibly develop in such a short time frame could deflect or destroy a black hole. Our only option would be to watch, calculate, and prepare for the end. But what exactly would that end look like? Stay with me, because the next section is where we begin the actual simulation. And I guarantee the timeline will shock you. Let's run the simulation. It's a Tuesday morning, perfectly ordinary. Astronomers at the European Southern Observatory in Chile notice something strange in their data. An anomaly. A distant star in the constellation Sagittarius has shifted position ever so slightly over the past 6 months of observations. Then another star nearby shows the same shift. They're not moving randomly. They're being deflected by something massive passing between us and them. Something invisible. Within 3 weeks, observatories worldwide confirm it. A stellar mass black hole, approximately 10 solar masses, is moving through space in our direction at 150 kilometers per second, about 335,000 miles per hour. Its trajectory will bring it into our solar system. The initial calculations suggest it will cross Neptune's orbit in approximately 50 years. The news breaks globally. Stock markets collapse. Religions splinter into factions. Some governments deny it. Others begin preparing. But here's what the news reports won't tell you clearly. The effects will begin long before the black hole gets anywhere near the inner solar system. Let me paint you the timeline, and I want you to really absorb this. Year 1 to year 10 after detection. This is the calm before the storm. The black hole is still beyond the Kuiper belt, that region of icy objects beyond Neptune where Pluto resides. Life on Earth continues more or less normally, though psychologically humanity is forever changed. Scientists refine their calculations. The black hole's path will take it through the outer solar system, likely passing somewhere between Jupiter and Saturn's orbits. It won't hit anything directly, but direct hits aren't the problem. Gravity is year 10 to year 25. The black hole crosses the heliopause, the boundary where the sun's solar wind gives way to interstellar space. This is about 120 astronomical units from the sun, about 120 times the distance from Earth to the sun. And this is where things start to go wrong in ways most people wouldn't expect. The Oort cloud, a spherical shell of billions of icy objects surrounding our solar system at distances up to 100,000 astronomical units, begins to feel the black hole's influence. Here's what happens. The black hole's gravity doesn't just pull objects toward it. It distorts the fabric of spacetime itself, creating what physicists call tidal forces. Objects closer to the black hole experience stronger gravity than objects farther away. This difference in gravitational pull stretches things. And in the Oort cloud, billions of comets that have been in stable, distant orbits for billions of years suddenly feel a tug they've never felt before. Dr. David Jewett at UCLA, who discovered the first Kuiper belt object in 1992, has studied how gravitational perturbations affect distant solar system objects. His research suggests that even a modest gravitational disturbance could send thousands of comets into the inner solar system. Now multiply that by the influence of a black hole, and you're looking at millions of comets suddenly having their orbits disrupted. Some get flung out of the solar system entirely, escaping into interstellar space. Others, and this is the nightmare scenario, get redirected inward, toward the sun, toward the planets, toward Earth. Year 25 to year 40 the comet storm begins. Astronomers detect thousands, then tens of thousands of new objects appearing in their telescopes, all moving inward. Most will miss Earth. Of course, space is vast, and we're a small target. But most isn't all. Statistical models suggest Earth could face anywhere from dozens to hundreds of impacts over this period, each one potentially catastrophic. We're talking about extinction-level events happening not once, but repeatedly, as waves of comets perturbed by the black hole's passage rain down on the inner solar system. This isn't science fiction. We know comets have hit Earth before. The impact that killed the dinosaurs 66 million years ago was likely an asteroid, but comets have struck too. In 1994, astronomers watched as comet Shoemaker-Levy 9, torn apart by Jupiter's gravity, crashed into the gas giant in a series of impacts that left scars the size of Earth in Jupiter's atmosphere. Jupiter protected us that time. But in our simulation, Jupiter itself is in trouble. Year 40 to year 50, the black hole is now in the outer solar system, somewhere between Uranus and Saturn. And this is where the real devastation accelerates. Neptune, the outermost ice giant, has already had its orbit significantly altered. Uranus is next. Here's what most people don't realize. The solar system is a delicately balanced system that took billions of years to stabilize. The planets are in what's called orbital resonance. Their orbits relate to each other in specific mathematical ratios that keep the system stable. Jupiter's orbit, for instance, helps protect the inner solar system by ejecting asteroids and comets with its massive gravity. But when you introduce a black hole into this equation, everything falls apart. The gravitational calculations done by planetary scientist Konstantin Batyin at Caltech, famous for predicting the possible existence of Planet 9, show how sensitive planetary orbits are to additional massive objects. His models demonstrate that even a Mars-sized object in the outer solar system could destabilize Neptune's orbit over time. A 10 solar mass black hole wouldn't destabilize it over time. It would wreck it almost immediately on cosmic timescales. Think of it like this. Imagine a perfectly balanced mobile hanging from a ceiling with planets as the weights. Now imagine grabbing one of those weights and yanking it. The whole thing starts swinging chaotically. That's what's happening to our solar system. Neptune's orbital velocity changes. It might start drifting outward or inward, depending on exactly how the black hole's trajectory intersects with it. If Neptune drifts inward, it could destabilize Uranus. If Uranus destabilizes, it could affect Saturn. And if Saturn's orbit changes, even slightly, Jupiter feels it. This is a cascade effect, and there's no stopping it. Here's the truly mind-blowing realization. By year 50, even though the black hole itself might still be years away from the inner solar system, Earth is already doomed. Not because the black hole will hit us, it almost certainly won't, but because the solar system itself, our cosmic home for 4.6 billion years, is coming apart at the seams. And we haven't even talked about what happens to the sun. That's next, and I promise you, it's even worse than you're imagining. Year 50 to year 60, the black hole is now in the realm of the gas giants. And this is where our simulation enters truly apocalyptic territory. Let's focus on Jupiter first, because what happens to Jupiter determines the fate of the entire inner solar system, including Earth. Jupiter is more massive than all the other planets combined. It's 318 times Earth's mass, and its gravity has been our guardian for billions of years. Astronomers call it the solar system's vacuum cleaner, because its immense gravity attracts asteroids and comets that might otherwise hit Earth. But now Jupiter faces something even its mighty mass cannot defend against. As the black hole passes through the outer solar system, Jupiter's orbit begins to change. Remember, the black hole is 10 solar masses, about 3,000 times more massive than Jupiter. When two massive objects pass near each other in space, they engage in what's called a gravitational slingshot. This is actually how we send spacecraft to distant planets. We use a planet's gravity to accelerate the probe. But in this case, Jupiter isn't getting a helpful boost. It's being fundamentally disrupted. Here's what the math shows, and this comes from N-body simulations run by astrophysicists studying stellar encounters. If the black hole passes within about 3 to 5 astronomical units of Jupiter, roughly the distance from the Sun to Jupiter itself, it could do one of several things. It might accelerate Jupiter enough to eject it from the solar system entirely, sending our largest planet into interstellar space as a rogue planet. Or it might slow Jupiter down, causing it to fall inward toward the Sun. Or, in the most chaotic scenarios, it could destabilize Jupiter's orbit so severely that Jupiter ends up on a highly elliptical path, swinging from the outer solar system to the inner solar system and back. Each of these scenarios is catastrophic for Earth, but in different ways. If Jupiter is ejected, we lose our protector. The asteroid belt, held in check partly by Jupiter's gravity, becomes unstable. Mars' orbit could change. Earth suddenly faces a bombardment threat unlike anything in billions of years. If Jupiter falls inward toward the Sun, it would pass through the inner solar system, and its gravity would wreak havoc on every inner planet's orbit, including ours. But here's the scenario that keeps astrophysicists up at night. What if the black hole passes close enough to Jupiter to not just disrupt its orbit, but to actually start pulling matter away from the planet? This is where we need to talk about the Roche limit and tidal disruption, and I promise this will blow your mind. The Roche limit named after French astronomer Édouard Roche, who calculated it in 1848, is the distance at which tidal forces from one body overcome the gravitational self-attraction of another body. Get closer than this limit, and the smaller body gets torn apart. For a black hole of 10 solar masses and an object like Jupiter, that Roche limit is approximately 1 million kilometers, about 0.007 astronomical units. That sounds like a safe distance. Like the black hole would have to get really close to threaten Jupiter directly. But here's the thing. Space is big, but planetary orbits span huge distances, and the black hole is moving through the solar system for years. The probability of a close pass isn't as low as you'd hope. If the black hole does pass within the Roche limit of Jupiter, here's what happens. Jupiter begins to be stretched. The side facing the black hole experiences stronger gravity than the side facing away. Jupiter isn't a solid rock. It's mostly hydrogen and helium gas. It starts to elongate, forming what astronomers call a tidal tail, streams of gas being pulled away from the planet toward the black hole. Within hours to days, depending on the exact distance, Jupiter could lose a significant fraction of its atmosphere. This material doesn't just disappear. It forms an accretion disk around the black hole, spiraling inward, heating up to millions of degrees as it compresses, and emitting tremendous amounts of X-rays and radiation. Suddenly, our solar system has a second source of intense radiation, and it's moving, unpredictable, deadly. Any spacecraft in the outer solar system would be fried. Any planets in the path of those radiation beams would face atmospheric stripping. But even if Jupiter survives relatively intact, just gravitationally disrupted, the cascade has already begun. Saturn, the second largest planet, is next in line. And here's where the simulation shows something unexpected. Saturn's rings might save us, at least temporarily. Let me explain. Saturn's rings are made of billions of pieces of ice and rock, ranging from tiny grains to house-sized chunks, all orbiting in a thin disk around the planet. These rings are held in place by a delicate gravitational balance. When the black hole's gravity disrupts Saturn, those rings would scatter. Trillions of tons of ice and rock suddenly freed from their orbital prison, flung in all directions. Some would rain down on Saturn. Some would be ejected from the solar system. And some, this is the unexpected part, could form a temporary debris field that might actually shield the inner solar system from some of the chaos happening in the outer system. This idea comes from recent research by Dr. Robin Canop at the Southwest Research Institute, who studies how planetary rings form and evolve. Her models show that when rings are disrupted, the debris doesn't just disappear instantly. It spreads out, creating a diffuse cloud that can persist for years. In our simulation, this debris cloud, combined with material from Jupiter and the comet storm from the Oort cloud, would create an unprecedented debris field between the outer and inner solar system. Some of this debris would eventually fall into the sun. Some would collide with planets. And some would create a spectacular but terrifying sky show visible from Earth, assuming anyone's still looking up. Because by year 60, Earth's situation has become dire, even if the black hole itself is still beyond Mars' orbit. The climate is collapsing, the social order is breaking down, and the sun itself is starting to react to the gravitational disturbance in ways we need to discuss next. Here's your retention oak. What if I told you that the black hole doesn't need to get anywhere near the sun to disrupt it? And what if I told you that the sun's reaction to the black hole might actually be worse than the black hole itself? Stay with me. Year 60 to year 70, the black hole is now in the inner solar system, somewhere between Mars and Earth. And this is where everything we think we understand about our safe, stable solar system gets turned upside down. Let's talk about what's happening to the sun, because this is the part of the simulation that shocked even the scientists running the models. The sun isn't just sitting there passively while a black hole invades its domain. The sun is a massive, dynamic ball of plasma held together by its own gravity, powered by nuclear fusion in its core. and it's connected to every planet in the solar system through something invisible but incredibly powerful: the heliosphere and the solar magnetic field. Here's what most people don't know. The sun's gravity extends far beyond what you see in the sky. Its gravitational influence reaches past the Oort cloud, almost halfway to the nearest star. When a black hole enters this gravitational domain, the sun responds. Not consciously, of course, but physically. The sun's position in space starts to shift. This might sound impossible. How can something as massive as the sun be moved by anything? But remember, the black hole is 10 solar masses. It has more gravitational pull than the sun itself. When it gets close enough, say, within a few of the sun, and the black hole actually begin to orbit their common center of mass, called the barycenter. It's the same principle that makes the Earth and Moon orbit their barycenter, which is why the Moon doesn't orbit the exact center of Earth. But in this case, the effect is dramatic. As the sun begins to shift position, even slightly, we're talking movements of millions of kilometers. But that's slight on astronomical scales. Every planet's orbit is affected. Earth's orbit is defined by our velocity and the sun's gravity. If the sun moves, the shape of our orbit changes. We might end up on a more elliptical path, swinging closer to the sun at some points and farther away at others. Or we might start drifting outward or inward. Dr. Eliza Quintana at NASA's Goddard Space Flight Center has studied planetary orbital stability using computer simulations. Her work on exoplanets shows how sensitive orbital systems are to perturbations. In one study, she demonstrated that if a Jupiter-mass planet in another solar system had its orbit changed by just 5%, the entire system could destabilize within a few thousand years. In our simulation, we're talking about changes far more dramatic, happening far more quickly. But here's the truly terrifying part that most discussions of black holes miss. The sun might start to react violently. Let me explain the mechanism. The sun's energy output is remarkably stable on human timescales. It varies by only about 0.1% over its 11-year solar cycle. This stability is due to a delicate balance between the crushing force of gravity trying to compress the sun and the outward pressure from nuclear fusion pushing back. This balance has been stable for 4.6 billion years. But when external gravitational forces start pulling on the sun, that balance gets disrupted. The sun's internal structure, the core, radiative zone, and convective zone, could experience stress. This stress could trigger increased solar activity, more sunspots, more solar flares, more coronal mass ejections. These are massive eruptions of plasma and magnetic field from the sun's surface that can reach Earth and wreak havoc on our technology. In 1859, the Carrington event, named after astronomer Richard Carrington, who observed it, was the most powerful solar storm in recorded history. It caused telegraph systems worldwide to fail, shocked operators, and created auroras visible near the equator. If a similar event happened today, it would cause trillions of dollars in damage to our electrical grids and satellite systems. Now imagine not one Carrington event, but dozens or hundreds as the sun convulses under gravitational stress from a passing black hole. But we haven't even gotten to the worst part yet. Remember that accretion disk I mentioned earlier, forming from Jupiter's atmosphere if the black hole got close enough? By year 70, that accretion disk has grown. The black hole has been sweeping up material as it moves through the solar system comets, asteroids, possibly even small moons. All of this material is spiraling into the black hole, heating up to millions of degrees and emitting intense X-rays and gamma rays. This radiation is deadly. Earth's atmosphere can protect us from some of it, but not all. The ozone layer, which shields us from harmful ultraviolet radiation, could be stripped away by high-energy particles from the accretion disk. Without the ozone layer, surface life would be exposed to sterilizing radiation from both the sun and the black hole's accretion disk. Think of it like this. Imagine Earth as a house and the atmosphere as the roof. Now imagine someone starts shooting holes in the roof with a high-powered rifle. Each hole lets in more rain, more wind, more destruction. The gamma rays and X-rays from the accretion disk are punching holes in our atmospheric roof, and there's no way to patch them. Here's what satellite observations have shown us about atmospheric loss. Mars lost most of its atmosphere billions of years ago, likely due to solar wind stripping it away after Mars lost its magnetic field. NASA's MAVEN mission, which has been orbiting Mars since 2014, measured this process directly. Earth has a magnetic field that protects us better than Mars, but even our magnetic field has limits. If the radiation from the black hole's accretion disk is intense enough, it could overwhelm even Earth's magnetic defenses. Year 70 to year 8, the black hole makes its closest approach to Earth. Let's say it passes at a distance of 1 astronomical unit, about 150 million kilometers, the distance from Earth to the Sun. That might sound safe. It's not. At that distance, Earth's orbit is catastrophically disrupted. We might be accelerated, slowing our orbital velocity and causing us to fall toward the Sun. Or we might be slowed down, causing us to drift outward into a colder orbit. Or, in the worst-case scenario, we might be captured by the black hole itself, beginning a long, deadly spiral toward oblivion. But here's the mind-blowing revelation. Even if none of those things happen, even if we somehow maintain a relatively stable orbit, Earth itself would be torn apart from within. The tidal forces at 1 astronomical unit wouldn't be strong enough to overcome Earth's self-gravity. We wouldn't be ripped into chunks like Jupiter might be. But the tidal forces would be strong enough to trigger massive geological upheaval. Earthquakes, not small ones. We're talking magnitude 9, magnitude 10, possibly even magnitude 11 earthquakes magnitudes that don't exist on the current scale, because nothing on Earth has ever triggered them. The entire crust of the planet would flex and crack. Volcanoes worldwide would erupt simultaneously. The tidal forces from the black hole would be like the moon's tidal forces that cause our ocean tides, except millions of times stronger. Instead of water sloshing back and forth, the solid ground would be sloshing, rising and falling by meters or even kilometers. Dr. Seth Stein at Northwestern University, a geophysicist who studies earthquakes in Earth's interior, has modeled what extreme tidal forces could do to a planet. His research on tidal heating of Jupiter's moon, Io, the most volcanically active body in the solar system, shows that tidal forces from Jupiter and Europa squeeze and stretch, generating enough heat to keep its interior molten. Earth would experience something similar as the black hole passes. Our interior, already partially molten, would heat up dramatically. The magnetic field, generated by the motion of molten iron in Earth's core, might intensify or destabilize. And I haven't even mentioned the oceans yet. Picture this: tidal forces that would raise and lower sea level not by meters, but by hundreds of meters, creating tsunami waves that would make the 2004 Indian Ocean tsunami look like ripples in a bathtub. Coastal cities gone, low-lying countries submerged. The geography of Earth would be rewritten in a matter of hours or days. Year 80 and beyond, if Earth somehow survives the close passage, we face a new reality. We're no longer in the solar system we evolved in. Our orbit has changed. The other planets, if they still exist and haven't been ejected or destroyed, are in different positions. The sun might be dimmer or brighter depending on how its internal balance was affected. The moon, we need to talk about the moon. The moon is held in orbit around Earth by mutual gravity. But when the black hole passes nearby, the moon's orbit could be disrupted too. It might be torn away from Earth, becoming its own planet orbiting the sun. Or it might crash into Earth, an impact that would liquefy both bodies and create a new, larger planet from the debris. Or it might survive, but in a different orbit, closer or farther, changing Earth's tides, seasons, and rotational stability. Without the moon in its current orbit, Earth's axial tilt, currently at 23.5 degrees and responsible for our seasons, would start to vary wildly over thousands of years. This is what happened to Mars, which has no large moon to stabilize it. Mars's axial tilt varies from 0 to 60 degrees over millions of years, causing extreme climate swings. Earth would face the same fate. Are you starting to see the full picture? A black hole entering the solar system doesn't just destroy things by swallowing them. It destroys the system itself, the delicate gravitational choreography that makes life possible. And here's the kicker we're about to explore. Humanity would see all of this coming, year by year, unable to stop it, forced to watch our cosmic home unravel. What would we do? How would we react? That's what we need to discuss next. And I promise, the human response to this scenario is just as fascinating as the physics. Let's shift gears and talk about something we haven't addressed yet. What would humanity actually do in this scenario? Because the physics is one thing, but the human response, the psychology, the politics, the desperate scramble for survival, that's where this simulation becomes not just a scientific thought experiment, but a mirror showing us who we are at our core. Imagine we're at year 5 after initial detection. The black hole is confirmed, its trajectory calculated with increasing precision. Governments worldwide are facing a problem that makes climate change look simple. Climate change, at least, offers the possibility of intervention, of mitigation, of adaptation. A black hole offers none of that. There is no technology, no policy, no amount of cooperation that can deflect it or destroy it. We're cosmically helpless, and that realization would shatter the human psyche in ways we can barely predict. Here's what the psychological research suggests, and this is based on actual studies of how humans react to existential threats. Dr. Sheldon Solomon at Skidmore College, one of the founders of terror management theory, has spent decades studying how awareness of mortality affects human behavior. His research shows that when people are reminded of their death, they cling more tightly to their cultural worldviews and become more hostile to outsiders who threaten those worldviews. Now scale that up to an entire species being reminded of its mortality constantly for decades. The social fabric would fray. Some people would become deeply religious, seeking comfort in the belief that their consciousness will survive even if their bodies don't. Others would become hedonistic, deciding that if the end is inevitable, they might as well enjoy what time remains. Still others would become violent, either out of despair or a desperate desire to control something in a situation where they control nothing. But here's what's fascinating. We'd also see the best of humanity emerge. History shows that humans are capable of extraordinary cooperation in the face of shared threats. After detection, I believe we'd see an unprecedented global scientific collaboration. Every telescope, every spacecraft, every computational resource would be dedicated to refining our understanding of the black hole's trajectory and its effects. We'd see the smartest minds from every nation working together, sharing data freely, because national secrets seem absurd when the entire world faces the same fate. Projects would begin. Desperate, probably futile projects, but projects nonetheless. I'm talking about serious scientific proposals that are being discussed even now for different scenarios. For instance, the concept of generation ships, massive spacecraft designed to carry thousands of people on journeys lasting centuries to other star systems. These aren't science fiction anymore. Organizations like the 100-Year Starship Project, funded initially by DARPA and NASA, are seriously studying the engineering challenges. In our simulation, by year 10, construction might begin on multiple generation ships. The goal: to preserve humanity and Earth's biosphere by sending representatives to potentially habitable exoplanets. Proxima Centauri b, an exoplanet orbiting the nearest star to our Sun, just 4.24 light-years away, would be the primary target. With current propulsion concepts, things like nuclear pulse propulsion or laser sails, being studied by the Breakthrough Starshot Initiative, we might be able to accelerate a spacecraft to 10 to 20% of light speed, making the journey take 20 to 40 years instead of thousands. But here's the brutal math. These ships couldn't carry everyone. If we're generous and say we could build ships carrying 10,000 people each, and we could launch 10 such ships before the black hole's effects become catastrophic, that's 100,000 people saved out of 8 billion. The selection process alone would tear society apart. Who gets to go? The youngest and healthiest? The smartest? The richest? The most genetically diverse? There's no fair answer, and every choice would be agonizing. Then there are the people who would refuse to leave. The ones who'd say, Earth is my home, and if Earth dies, I die with it. I suspect that would be most people, actually. The psychology of place attachment is powerful. Astronauts report feeling profound emotional connections to Earth when viewing it from space. The overview effect, as it's called. For most people, the idea of abandoning Earth wouldn't just be logistically impossible. It would be emotionally unthinkable. By year 20, as the comet storm begins and the first impacts start hitting Earth, we'd see what disaster preparedness experts call catastrophic social fragmentation. Governments would struggle to maintain order. Supply chains would collapse as people abandon their jobs to spend time with loved ones. Who wants to work in a factory making widgets when the world is ending? Money would lose meaning. Power would shift to those who control resources: food, water, shelter, weapons. But, and this is important, we'd also see acts of breathtaking compassion. Research from disaster zones shows that most people don't panic or turn violent. They help each other. After Hurricane Katrina, after 9/11s, after every major disaster, the dominant human response is mutual aid. Yes, there's looting and violence, but those are the exceptions, not the rule. I believe that even facing cosmic annihilation, most humans would comfort each other, share what they have, and face the end with dignity. There would be art, so much art, music, paintings, literature, films, all grappling with the end. Some would be angry, raging against the dying of the light. Some would be peaceful, accepting, even celebratory of the beauty we experienced. The Voyager golden records, sent into space in 1977, carrying sounds and images of Earth, were meant as a message to potential alien civilizations. In our scenario, we'd create similar time capsules on a massive scale, launching thousands of them into space in all directions, hoping that someday someone somewhere might find them and know that we existed, that we loved, that we meant something. By year 30, as Saturn and Jupiter's orbits visibly change and the night sky starts looking wrong planets in different positions than they should be, unfamiliar constellations, as Earth's orbit shifts, people would gather, families would come together. Old feuds would be forgotten. The terminally ill would stop treatment and spend their final months with loved ones. Children would be shielded from the truth as long as possible, and told with tenderness and love that we're all going on a great adventure together. And scientists would keep working. Right up until the end, they'd keep observing, recording, transmitting data to whatever probes we'd managed to launch toward interstellar space, preserving humanity's final scientific observations for whoever might find them, because that's what we do. We observe. We measure. We try to understand. It's hardwired into us. Here's the revelation that this section is building to. Facing a black hole wouldn't just be about the physics of orbital mechanics and tidal forces. It would be a test of what it means to be human. Are we just atoms and molecules following physical laws? Or is there something more, some spark of consciousness, of meaning, of purpose that transcends the material? The black hole doesn't care. The universe doesn't care. But we care. And that caring, that desperate, defiant insistence that our lives matter even in the face of cosmic indifference, that might be the most profound thing in the universe. What if I told you that contemplating this scenario right now, in this moment, might actually change how you live your life? We're going to explore that next, and I promise, it's going to get personal. It's time to bring this home. It's time to make this about you, specifically you, watching this video right now. You're not facing a black hole. You're safe. The solar system is stable. You'll go to sleep tonight and wake up tomorrow morning, and the sun will rise just like always. But here's the uncomfortable truth. You're going to die anyway. Not from a black hole, but from something. Heart disease, cancer, an accident, old age, something. Your death is 100% certain. And unlike the black hole scenario, you don't even know when it's coming. Could be 50 years from now. Could be tomorrow. So what's the difference, really, between humanity facing a black hole in 50 years and you facing your own personal mortality at some unknown point in the future? The answer is, there isn't much difference. The certainty of death combined with the uncertainty of timing creates the same existential crisis on an individual scale that the black hole creates on a species scale. This is where a lot of viewers check out mentally because it's uncomfortable. But stay with me. This is the most important part of this entire video. The black hole scenario isn't just a fun thought experiment about orbital mechanics. It's a cosmic mirror forcing us to confront questions we spend most of our lives avoiding. What matters when the end is inevitable? How should we spend our limited time? What gives life meaning in a universe that doesn't care about us? Let's think about your life right now. What percentage of your time do you spend doing things that genuinely matter to you versus things you do out of obligation, habit, or distraction? Be honest. For most people, the ratio is depressing. We spend hours scrolling social media, consuming content that we forget within minutes. We work jobs we don't care about to buy things we don't need. We postpone conversations with loved ones, assuming there will always be more time. We put off our dreams, our creative projects, our adventures, telling ourselves someday. In the black hole scenario, there is no someday. There's only now and a finite countdown. And you know what would happen. People would stop wasting time. They'd call their estranged family members and reconcile. They'd tell people they love them. They'd write that book, paint that painting, take that trip, have that conversation. Because suddenly, with the end in sight, the trivial falls away and what truly matters comes into sharp focus. But here's the mind-blowing realization. You already have a countdown. You just don't know the number. And psychologically, not knowing the number makes it easier to ignore, to pretend you have infinite time. You don't. None of us do. And the black hole scenario, as terrifying as it is, offers a strange gift. Clarity. Absolute, undeniable clarity about what matters. Dr. Irvin Yalom, an existential psychologist at Stanford, has written extensively about how confronting mortality can be therapeutic. He works with terminal cancer patients and has observed that many of them, after the initial shock and grief, report living more fully than they ever did before. They stop sweating the small stuff. They focus on relationships and experiences. They feel more alive, knowing they're dying than they did when they thought they had forever. This is the paradox. Death gives life meaning. If we lived forever, nothing would have urgency. There would be no reason to do anything today, because there would always be tomorrow. It's the limitation, the scarcity, the finitude of time that makes each moment precious. The black hole scenario just makes that truth impossible to ignore. Let me ask you something personal. What would you do differently if you knew for certain that the world was ending in 50 years? Really think about it. Would you keep the same job? Would you maintain the same relationships? Would you spend your evenings the same way? Write down your answer mentally. Now here's the follow-up question. What's stopping you from making those changes right now, in this reality, where you don't know when the end will come? The answer for most people is fear. Fear of failure, fear of judgment, fear of change. We trade the life we want for the security of the life we have, even when that security is an illusion. Because here's the truth. There is no security. The universe is fundamentally uncertain. A black hole might not enter our solar system, but an asteroid could hit Earth tomorrow. A supervolcano could erupt. You could have an undiagnosed medical condition. The illusion of control and safety is just that, an illusion. And once you accept that, once you truly internalize that you're not in control and that everything is temporary, something shifts. It's terrifying at first, but then it becomes liberating. If nothing is guaranteed, if there's no safety and no certainty, then the only rational thing to do is to focus on what actually matters to you, not what society says should matter, not what your parents want, not what makes logical financial sense, but what lights you up inside, what makes you feel alive, what you'd want to be doing in those final years before the black hole arrives. Think about the people you love. When's the last time you told them? When's the last time you really connected, without phones, without distractions, just presence and attention? In the black hole scenario, people would cherish every moment with loved ones because they'd know how few moments remain. But you could choose to live that way now. You could put down your phone during dinner. You could call someone you miss instead of just thinking about calling them. You could forgive someone or ask for forgiveness today. Think about your work. Are you contributing something you're proud of? Something that would matter even if you knew it was all ending? Or are you just marking time, collecting a paycheck, waiting for retirement? In the black hole scenario, retirement is canceled. There's only now. So what work would be meaningful to you now? What could you create or contribute that would make you feel like your time mattered? Think about experiences. What have you always wanted to do but haven't? Travel somewhere? Learn an instrument? Write something? Build something? In the black hole scenario, people would make bucket lists and actually complete them because waiting is no longer an option. But why are you waiting? What are you waiting for? Permission? The right time? More money? Here's the secret. There's never a perfect time. The right time is now. The money you need might be less than you think. The permission you're waiting for has to come from yourself. Here's a specific example. Bronnie Ware, an Australian palliative care nurse, spent years caring for people in the final weeks of their lives. She wrote a book called The Top 5 Regrets of the Dying, based on what she heard from her patients. Want to know the number one regret? I wish I had the courage to live a life true to myself, not the life others expected of me. Not money, not success, not failure courage, the courage to be authentic. How many of us are living someone else's vision of what our life should be? The black hole scenario strips away all the bullshit, all the pretense, all the games we play pretending things that don't matter actually matter. It forces radical honesty and authenticity. And you can choose that right now without the black hole. You can decide today to stop living for external validation and start living for internal alignment. This is the personal connection I promised. The black hole entering our solar system is a metaphor for your own mortality. It's not a distant, abstract thing that happens to other people. It's coming for you, personally. And the question isn't whether you'll face it, you will. The question is whether you'll face it having lived fully or having postponed living until it was too late. Look, I know this is heavy. I know you probably opened this video expecting a fun science exploration, not an existential crisis. But science isn't just about facts and equations. It's about truth. And the truth is that we're all cosmic accidents, temporary patterns of matter and energy, alive for a brief instant on a small planet orbiting an average star in an incomprehensibly vast universe that will continue long after we're gone. That could be depressing. It could make life seem meaningless. Or, and this is the shift I want you to make, it could be the most liberating, empowering realization possible. Because if nothing has inherent meaning, then you're free to create your own meaning. You get to decide what matters, not the universe, not society, you. And that's terrifying. Yes, but also beautiful. You're free in a way you might not have realized. The black hole doesn't care about you. The universe doesn't care about you. But you care about you. And the people in your life care about you. And that caring, that connection, that love, that's what creates meaning in a meaningless universe. We're islands of complexity and consciousness in an ocean of entropy. And we're here for such a short time that every moment we waste on things that don't matter is a tragedy. So here's my challenge to you. Leave this video and do something different. Call someone you love and tell them. Forgive someone you've been holding a grudge against. Start that project you've been putting off. Book that trip. Have that conversation. Make one choice today that reflects who you actually want to be, rather than who you think you should be. Not tomorrow. Not next week. Today. Because the black hole might not be coming. But your time is still limited. And you don't get to know how much you have left. So use it. Use it like it matters. Because it does. Not to the universe, but to you. And that's enough. Stay with me. We've got more to explore, and the next section is going to blow your mind in a different way. We're going to talk about whether we could survive this scenario, and the answer is going to surprise you. Could we survive? That's the question that's probably been nagging at you this whole time. We've established that a black hole entering the solar system would be catastrophic. But catastrophic doesn't necessarily mean extinction. Humanity has survived ice ages, supervolcano eruptions, asteroid impacts, and plagues. We're resilient, adaptable, and increasingly technological. So is there any realistic scenario where some part of humanity makes it through? The answer is yes, but it requires us to completely reimagine what survival means. Let's explore the possibilities. And I'm going to take you through some scenarios that sound like science fiction, but are actually grounded in serious scientific research. Scenario 1. Underground cities. This is the most conservative approach. As the black hole's effects become clear comet impacts, climate disruption, tidal forces, the safest place to be is deep underground, insulated from both radiation and surface catastrophes. We've already built structures like this. Cheyenne Mountain Complex in Colorado, built during the Cold War, is a military installation built under 2,000 feet of granite, designed to survive a nuclear attack. Norway's Svalbard Global Seed Vault stores samples of the world's seeds in a mountain bunker in the Arctic. Now scale that up. Imagine massive underground cities, perhaps repurposed from mining operations, equipped with hydroponics farms for food, nuclear reactors for power, and water recycling systems. The technology exists today. The Deep Isolation Project is already working on boring machines that can create underground facilities quickly and efficiently. In our black hole scenario, by year 20, governments and private organizations could have constructed dozens of these facilities, each capable of housing thousands of people for years or even decades. But here's the catch. You're essentially asking people to become mole people, living in artificial light, eating synthesized food, never seeing the sky again. The psychological toll would be immense. Humans evolved on the surface, under the sun. Seasonal affective disorder shows us what happens when people don't get enough sunlight. Depression, lethargy, physical illness. Now imagine that, but permanent, for generations. The first generation would remember the surface world. The second generation would know it only from stories. By the third generation, would they even care about returning? Scenario 2. Orbital habitats. Instead of going down, go up. Space stations, but much larger. The International Space Station currently houses about 7 people. But concepts like the O'Neill cylinder, proposed by physicist Gerard O'Neill in 1976, could theoretically house millions. These are rotating cylindrical space habitats that use centrifugal force to create artificial gravity. The interior surface would be like living inside a can, but with the right engineering, you could create a remarkably Earth-like environment: parks, rivers, even weather systems. Building these would require resources from asteroids and the moon, which is why companies like Planetary Resources and Moon Express have been working on asteroid mining concepts. In our scenario, the black hole's approach would actually accelerate space resource development. Desperation breeds innovation. By year 30, we might have rudimentary orbital habitats at Earth's L4 and L5, Lagrange points gravitationally stable locations where the habitat would naturally remain in position relative to Earth. The advantage: orbital habitats could be moved. If Earth's orbit becomes unstable, the habitats aren't tied to Earth's fate. They could potentially be navigated to a safer orbit, or even pushed toward Mars if Mars' orbit becomes more habitable. But the disadvantage: they're fragile. One major impact from debris, one system failure, and everyone aboard dies. There's no wilderness to escape to, no backup plan. You're utterly dependent on technology, functioning perfectly, indefinitely. Scenario 3. Mars colonization. This is the Elon Musk solution. By the time of our black hole scenario, we might already have a Mars settlement thanks to SpaceX's plans. Mars is farther from the Sun than Earth, so it would feel the black hole's effects later and possibly less severely. If we could get a self-sustaining colony of tens of thousands of people on Mars by year 30, they might survive even if Earth becomes uninhabitable. But self-sustaining is doing a lot of work in that sentence. Mars has no breathable atmosphere, no magnetic field to protect from radiation, and no biosphere. Everything would have to be manufactured or grown in controlled environments. NASA's MOXIE experiment, which flew on the Perseverance rover, successfully demonstrated that we can make oxygen from Mars CO2 atmosphere, but scaling that up to support thousands of people. That's an engineering challenge that makes the Apollo program look simple. Dr. Robert Zubrin, founder of the Mars Society, has argued that Mars colonization is not only possible, but necessary for humanity's long-term survival. His Mars Direct plan proposes using local resources to manufacture fuel, building materials, and life support. In our black hole scenario, this wouldn't just be an interesting project. It would be essential. And here's the thing: humans work best under pressure. The Manhattan Project developed the atomic bomb in under 3 years because there was existential urgency. I believe that with global cooperation and unlimited resources devoted to the problem, we could have a viable Mars colony within 20 to 30 years. Scenario 4. Generation ships. We talked about this earlier, but let's go deeper. A generation ship is a spacecraft designed to travel between stars with a population that lives, reproduces, and dies aboard, with their descendants eventually reaching the destination. It's the ultimate backup plan. If the solar system is doomed, leave it entirely. The Breakthrough Starshot initiative, backed by people like Stephen Hawking and Yuri Milner, proposes using powerful laser arrays to accelerate tiny spacecraft to 20% of light speed. But those are small probes. A generation ship carrying thousands of people would need to be massive, potentially kilometers long, with its own ecosystem, farms, manufacturing facilities. The ISS costs about $150 billion. A generation ship might cost trillions, but in our scenario, cost is irrelevant. You can't buy your way out of a black hole, so every nation's wealth would be redirected toward survival projects. The challenges are immense. Can humans reproduce successfully in zero gravity? We don't know. It's never been tested. Can we create a truly closed-loop ecosystem that recycles everything indefinitely? We've tried with projects like Biosphere 2, and they've failed. Can we prevent genetic drift and inbreeding in a population of thousands isolated for generations? Maybe with careful genetic management. Can we prevent social collapse over a journey lasting decades or centuries? That might be the hardest question of all. But here's what gives me hope. Humanity has always been a species of explorers. We left Africa and spread across the globe. We crossed oceans without knowing what was on the other side. We went to the moon because it was hard. That drive, that restless curiosity, that refusal to accept limitations, that's encoded in us. If we knew the black hole was coming and we had decades to prepare, I genuinely believe we'd build those ships. Not enough to save everyone, but enough to save the spark. Enough to ensure that somewhere, on some distant world, humans would continue. Scenario 5. Digital consciousness. This is the most speculative, but it's being seriously researched. What if survival doesn't require physical bodies at all? What if we could upload human consciousness to digital substrates computers, essentially, and survive as digital entities? Dr. Randall Kying, a neuroscientist working on substrate-independent minds, believes that consciousness is fundamentally a pattern of information processing. If we could map every neuron and synapse in a human brain and replicate that pattern in software, we could theoretically create a digital version of that person that would be functionally identical. That digital person could be backed up, copied, transmitted as data across space at light speed. In our black hole scenario, by year 40, we might have the technology to upload at least some people. Their digital selves could be transmitted to probes headed for other star systems, arriving as information and potentially downloaded into robotic bodies or biological clones on the other end. It sounds insane. But is it any more insane than the alternative watching everyone die? The philosophical questions are endless. Is a digital copy really you, or just a copy that thinks it's you while the real you dies? Does consciousness even survive the transition, or would you experience death while a separate entity with your memories wakes up thinking it's you? We don't know. But desperate times might make those philosophical objections seem less important. Here's the synthesis of all these scenarios. Survival is possible, but it requires accepting that humanity might look very different on the other side. We might be underground dwellers who've never seen the sun. We might be spacefaring nomads with no planet to call home. We might be Martians, genetically and culturally diverged from our Earth ancestors. We might be digital ghosts, patterns of information, experiencing simulated realities. We might be all of those things, a fragmented species scattered across multiple platforms, no longer unified, but still recognizably human in our curiosity, our adaptability, our will to survive. And you know what? That might be okay. Evolution has always been about adaptation. We started as single-celled organisms in the ocean. We became fish, then amphibians, then reptiles, then mammals, then primates, then humans. Each transition required leaving behind the old form. A fish can't go back to being a single-celled organism. A human can't go back to being a primate. And post-black hole humanity might not be able to go back to being what we are now, but we'd still be us in the ways that matter. We'd still tell stories. We'd still love. We'd still look up at the stars and wonder. The black hole scenario forces us to confront what's essential about humanity versus what's contingent. Is being human about having carbon-based bodies? Or is it about consciousness, about the inner experience of being alive? Is it about living on Earth specifically? Or is it about the community, the culture, the continuity of memory and purpose? These aren't just philosophical questions. In our scenario, they're survival questions. And the answer we choose determines what we try to save. Here's your next mind-blown moment. Maybe the black hole is coming. Maybe not in 50 years, but in 50 million. Maybe it's a different threat, a gamma-ray burst, a rogue star, the sun's eventual death in 5 billion years. Whatever the specific threat, the fact remains. Earth won't be habitable forever. The universe is not our friend. And the only way for humanity or our descendants to survive the long term is to become multi-planetary, multi-stellar, eventually multi-galactic. The black hole scenario is just a compressed version of the challenge we already face. It's not hypothetical. It's just on a different timescale. So when I talk about these survival scenarios, I'm not just talking about science fiction. I'm talking about the future we need to build anyway, if we care about anything beyond our own lifetimes. The generation ships, the Mars colonies, The underground cities, these aren't just backup plans for unlikely catastrophes. They're the inevitable next steps for a species that wants to survive. Stick with me. We're entering the final sections now, and we're going to pull everything together. The physics, the psychology, the survival strategies, the personal meaning. By the end, you're going to see this whole scenario and your own life in a completely different light. Let's talk about something we've been dancing around but haven't addressed directly. The scientific debate about whether this scenario is even plausible. Because if you've been paying attention to astrophysics news, you might know that while rogue black holes exist, the probability of one actually entering our solar system is astronomically low. So is this whole video just fear-mongering about something that will never happen? No, and here's why the distinction matters. The probability of a stellar mass black hole passing through our solar system in the next million years is estimated at about 1 in 10 billion. Those are lottery-winning odds. You're statistically more likely to be hit by lightning while being attacked by a shark during an earthquake. So yes, it's incredibly unlikely. But unlikely is not the same as impossible. And more importantly, the improbability of this specific scenario doesn't diminish the value of thinking through its implications. Dr. Lisa Randall at Harvard, a theoretical physicist who studied extinction-level events, argues that we drastically underestimate low-probability, high-impact events. Her research suggests that a dark matter disk passing through the solar system might have triggered the comet impact that killed the dinosaurs 66 million years ago. The probability of any given dark matter perturbation hitting us is tiny, but over hundreds of millions of years, tiny probabilities add up. Unlikely things become inevitable given enough time. And here's the crucial point. The specific threat doesn't matter as much as the category of threat. Black holes, rogue stars, gamma-ray bursts, asteroid impacts, supervolcano eruptions, solar flares, nearby supernova. There are dozens of cosmic threats that could devastate or end civilization. Individually, each one is unlikely. Collectively, the probability that Earth will face some kind of cosmic catastrophe over the next million years approaches certainty. The Fermi paradox asks, if intelligent life is common in the universe, where is everybody? One proposed answer is the great filter sun challenge that all civilizations face that most fail to overcome. Maybe it's behind us, the jump from single-celled to multi-celled life. Or maybe it's ahead of us. Maybe most civilizations get wiped out before they can become multiplanetary because they're unlucky enough to face a cosmic catastrophe before they're technologically ready to handle it. Our black hole scenario is, in some ways, a thought experiment about the great filter. Could humanity, with current or near-future technology, survive an existential cosmic threat if we had 50 years warning? The answer, as we've explored, is maybe. With global cooperation, massive resource investment, and some luck, we might save a small fraction of our population and preserve our species. But here's what keeps me up at night. We might not get 50 years. We might get 5, or 5 months. The asteroid Apophis, discovered in 2004, will pass close to Earth in 2029, close enough that it will be visible to the naked eye. Initial calculations suggested a small but non-zero probability of impact. Further observations ruled it out for 2029, but Apophis will return in 2036, and then again in 2068. Each time, there's a gravitational keyhole, a specific region of space that, if the asteroid passes through it, would alter its orbit enough to guarantee an impact on a future pass. We're watching, we're calculating, but we're not in control. The Chelyabinsk meteor in 2013 exploded over Russia with the force of 20 to 30 atomic bombs. No one saw it coming. It approached from the direction of the sun, so our telescopes were blind to it. Over 1,500 people were injured by shattered glass from the shockwave. If it had been slightly larger, or had hit a more densely populated area, thousands could have died. And we didn't know it existed until it was already in our atmosphere. So when we talk about a black hole giving us 50 years warning, that's actually optimistic. That's best case scenario. Many cosmic threats won't be that polite. They'll arrive with little or no warning, and our survival will depend on whatever preparations we've made in advance, not scrambling responses during the crisis. This is why the black hole scenario matters, even if it never happens. It forces us to think about preparedness, resilience, redundancy. It forces us to ask, are we doing enough to ensure humanity's long-term survival? And the answer, honestly, is no. We're not. We have one planet. We have no self-sustaining off-world colonies. We have no generation ships. We have no backup. All of our eggs are in one basket called Earth, and we're treating that basket like it's indestructible. Dr. Martin Rees, the British astronomer royal, wrote a book called Our Final Hour, arguing that humanity has only a 50/50th chance of surviving the 21st century. Not because of cosmic threats, but because of self-inflicted ones. Nuclear war, bioengineered pandemics, artificial intelligence run amok, climate change. He argues that we're in the most dangerous period of human history because our technology has advanced to the point where we can destroy ourselves. But our wisdom hasn't advanced enough to ensure we won't. And you know what? I think he's right, but I also think he's not pessimistic enough. Because even if we avoid all the self-inflicted catastrophes, even if we achieve global peace and sustainable technology and wise governance, the universe will still eventually throw something at us that we can't control. It might be tomorrow. It might be in 1 billion years, but it's coming. The question is whether we'll be ready. The black hole scenario is a mirror forcing us to confront our cosmic vulnerability. We're not the center of the universe. We're not invulnerable. We're not even particularly special from a physics perspective, just another planet orbiting another star in an average galaxy. The universe doesn't care about us, and it doesn't have to actively try to kill us for us to die. All it has to do is be indifferent, and indifference is the universe's default state. But here's the beautiful, defiant, almost absurd thing. We care. Even if the universe doesn't, we do. We care about survival. We care about meaning. We care about each other. And that caring is enough to motivate us to do seemingly impossible things. We went to the moon not because it was necessary for survival, but because we wanted to. We built the Large Hadron Collider, a machine 27 kilometers in circumference, designed to smash particles together at nearly light speed, because we wanted to understand the fundamental nature of reality. We composed symphonies and wrote poetry and painted masterpieces not because they'd save us from cosmic threats, but because they make life worth living. The black hole scenario strips away the illusion of safety and forces us to confront reality. We're temporary, vulnerable, cosmically insignificant. And yet, we're also the universe becoming aware of itself. We're matter organized in such a way that it can contemplate its own existence, feel awe at the beauty of a sunset, and love another person so deeply it hurts. That's not nothing. That's everything. So is the black hole coming? Probably not. Not in our lifetimes, anyway. But something is. And the work we do now, the space programs, the backup plans, the technology development, the cultural maturation, that work determines whether humanity is a flash in the cosmic dark or a light that spreads across the stars. Here's your penultimate mind-blown moment. You're part of that work. Not abstractly, but literally. Every choice you make ripples outward. If you become a scientist, maybe you contribute to the technologies that enable space colonization. If you become a teacher, maybe you inspire the next generation to care about these questions. If you become an artist, maybe you create something that preserves our culture for future generations. If you're a parent, you're literally creating the future. Your children or your students or the people you influence will be the ones making the decisions about humanity's long-term survival. And even if you never do any of those things professionally, you still matter. Because culture is created by all of us, collectively. The values we embrace, the questions we ask, the priorities we set, these shape what humanity becomes. If we collectively decide that short-term comfort matters more than long-term survival, we'll get one future. If we decide that exploration and resilience and audacity matter, we'll get a different future. The black hole scenario isn't a prediction. It's a choice. It's asking, what kind of species do you want us to be? Do you want us to be the species that huddles on one planet, hoping nothing bad happens, until something bad inevitably happens and we go extinct? Or do you want us to be the species that looks up at the stars, acknowledges the danger, and says, we're going anyway? I know which one I choose. The question is, what do you choose? And we're about to make that choice very, very concrete. Stay with me for the final section. We're here, the final section. And I want to do something different. I want to talk directly to you, person to person, about what you do with this information. Because we've spent 3.5 hours together exploring one of the most terrifying, awe-inspiring scenarios in astrophysics. We've looked at the science, the survival strategies, the personal implications, the cosmic perspective. And now what? You close this video and go back to your regular life? Maybe, or maybe something's changed. I hope something's changed. Because if I've done my job, you're not the same person who started watching this video. You've been forced to confront uncomfortable truths. You've seen the fragility of the solar system, the inevitability of cosmic catastrophe, the ultimate meaninglessness of existence in the face of an indifferent universe. And you've also seen the beauty of human defiance, the power of consciousness to create meaning where none exists, the precious, improbable miracle of being alive right now. So let's make this concrete. What are you going to do differently? Not in some vague, I should appreciate life more way. Specifically, today, this week. Are you going to call that person you've been meaning to call? Are you going to start that project you've been postponing? Are you going to have that difficult conversation? Are you going to make a change in your life that you've been afraid to make? Because if the black hole taught us anything, it's that waiting is a luxury we don't actually have. You're going to die. I'm going to die. Everyone you know is going to die. The sun will die. The earth will die. The universe itself will eventually die in heat death. All of it is temporary. And that could be depressing. It could make you feel small and insignificant. Or it could be the most liberating revelation of your life. Because if nothing lasts, then the only thing that matters is what you choose to do with your time right now. Not yesterday, that's gone. Not tomorrow, that's not guaranteed. Right now, this moment, this is all you have. This is all anyone has. And it's enough. I started this video with a scenario designed to shock you. A black hole entering the solar system, unraveling everything we take for granted. But the real shock isn't the black hole. It's the realization that you don't need a black hole to face your mortality and the impermanence of everything you love. You already are facing it. You always have been. Most of us just spend most of our time in denial. So here's my challenge. Live like the black hole is coming. Not in a panic, not in despair, but with clarity, with intention, with appreciation for the absurd, beautiful accident that is your existence. You didn't ask to be born. You didn't choose this planet, or this solar system, or this moment in history. But here you are anyway, a conscious being in a mostly unconscious universe, capable of wonder and love and meaning-making. What will you do with that? What will you create? What will you contribute? How will you love? How will you face the end when it comes not a black hole, but your own personal end? Because it is coming, and the only question is whether you'll face it having lived fully or having postponed living. I want to leave you with one final thought, and it comes from Carl Sagan, the astronomer and science communicator who did more than anyone to help people understand our place in the cosmos. He talked about the pale blue dot, that famous photograph of Earth taken from Voyager 1 when it was leaving the solar system. In that image, Earth is a tiny speck, barely visible, suspended in a sunbeam. And Sagan said, "Look again at that dot. That's here. That's home. That's us. On it everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species, live there on a mote of dust suspended in a sunbeam. That's us. That's all of us. And in our black hole scenario, that mote of dust gets disrupted, possibly destroyed, and everything we've built and everyone we've been disappears as if we never were. But we were. We are. Now. And that mattering, that insistence on meaning and purpose and love in the face of cosmic indifference, that's the most profound thing in the universe. The black hole doesn't care. The universe doesn't care. But we care. You care. And you get to choose what that caring looks like. You get to choose what kind of human you want to be, what kind of life you want to live, what legacy you want to leave. Not a legacy of buildings or money or fame, those are all temporary. But a legacy of impact, of kindness, of moments shared, of lives touched, of having been present and real and fully yourself. If you take nothing else from this video, take this. You matter. Not because the universe says so, but because you say so. And that's enough. That has to be enough. Because it's all we have. Thank you for taking this journey with me. Thank you for staying to the end. Thank you for caring enough about big questions to spend 3.5 hours exploring them. You didn't have to. You could have been doing anything else. But you chose this. And that choice says something beautiful about who you are. Now go. Go live. Go love. Go create. Go be the person you want to be before the end comes. Not because a black hole is coming, but because you are. You're here right now, alive and conscious and capable of anything. Don't waste it. Don't postpone it. Just live it. And if you found value in this video, share it. Not because I need the views, but because maybe someone else needs to hear this. Maybe someone else is stuck or scared or postponing their life, and maybe this perspective could help them the way I hope it's helped you. Subscribe if you want more content that makes you think, that challenges you, that takes you on journeys to the edge of human knowledge and understanding. Leave a comment telling me how this affected you, what you're going to do differently, what your takeaway is. I read every single one, and I care about your perspective. This is the end, but it's also the beginning of whatever you choose to do next. Make it count. You don't get another chance. None of us do. The black hole is a metaphor, but the urgency is real. Your time is limited, so use it. Use it like it matters. Because to you, and to the people who love you, it does. Thank you. And go live your life like you mean it.